I'm going to go ahead and do 13, 18, and 19 today. So starting with 13, most of this is going to be like doubling time. And so we see that we're wanting to use this doubling time equation. So it's something that should have gone over, but it's going to be this equation here. So we have m of t is equal to, m of t is like this resulting mass. So we're trying to see, like, we have this doubling time or this rate that we're doubling, and we're seeing like, okay, how much time does it take to get to a certain mass? And so m naught here is going to be our initial mass. So it's like what we start off with, and then we have our doubling base of 2 because we have a doubling time. And then we have time over your doubling time, or like your doubling rate. So time is like how much would you double by, or what would your resulting mass be after like 5 years or something. Whereas doubling time, like in this problem, we're given that doubling time is an hour. So for part A, we're given that there are initially X milligrams of bacteria, and we're wanting to express the mass as a function of T. So they use F, we use an M, that's fine. So Ft is going to be equal to our initial mass, which they're giving us, that's X. So X times 2. And then the, fixing that there, our time, we don't know, but that's going to be the T. And then our doubling time was 1, so it's T over 1. So it's just 2, T. So you should just have X to the 2T. Okay, and then B, we're going to use part A to complete the equation whose solutions at the time, which there are 3x milligrams of bacteria. So 3x is like our resulting mass, and we're trying to see how long it takes to get that. So we're basically just saying 3x equal to our doubling equation that we found in part A. So it should just be 3x is equal to x to the 2t. And we don't have to solve it. So you're just plugging in x through 2t into WebWork. Part C is when we're actually solving for t. And so we set 3x equal to x to 2t. So I just divide both sides by x here. And I could just do this over. Alright, so I divide both sides by x. I get 3 is equal to 2t. And then now I want to get the t out from the exponent. And so I go ahead and take the natural log of both sides. And so I could use my log rules to get the t out in front. So I have a natural log of 3 is equal to t times natural log of 2. Now I want to get t by itself, so I divide both sides by natural log of 2. And then I get t is equal to natural log of 3 divided by natural log of 2. And you could just plug these into a calculator. You could input it into WebWork like that. But basically, you could just plug those into a calculator, see what they get you, or use your table. And it's about 1.58. And so we just want to do that to see for part D. We did check that it's between 1 and 2 hours, basically. And we want to understand why that has to be. And so essentially, right, we were trying to figure out when T would be for the population to be 3 times X. So that's basically like tripling the population. Whoop, moved it a little bit. That's tripling the population, right? And so our equation was for doubling the population. And so it's going to take a full hour to double it, right? That was the doubling time takes an hour. So our answer was 1.58. So yeah, it did double it in that 1 hour. But then it takes a little bit extra time to triple it, to do 3x times it, not just 2x. And then we're almost to 4. So it's the 1.58. So that does make sense because we have the hour to double it, and then we have a little extra, the 0.58, to triple it. So 18, we have this table of values for the graph of y is equal to 2x. And so we just want to fill in the missing values of the table and then just match the graph. And so this one shouldn't be too bad. Basically what we're doing is part A. Let's just plug in x equals -1. So I have y is equal to 2 to the -1. And the same thing with B, we're going to do y is equal to 2 squared. So to the -1, remember the negative exponent flips it, so it should be a 1/2. It flips it as a fraction, so you have like a 1/2 to the first power, but we don't need to write that first power. And then 2 squared is just 4. So we should have this -1 is going to be 1/2, and then at this 2 we should have 4. Alright, and then the graph that best matches the one you drew. So we mainly want to be looking out for the 2 to match the 4 and the -1 to match the 1/2. And the only graph that does that for me, it might be a different letter for you, but it was E for me. So we can see that because at 2, we hit pretty close here to 4. So we have that 0.24. And then we also have -1 hits the graph at 1/2 as well. So that was just a sample of the points that we have. And that was the graph that matched it. So you just want to see which graph has the points that we found. And then the other points too. You could check like 1 gets matched to 2 as well. And some of the other points. So for 19, it basically looks like number 13, except now we have kind of 2 equations that we're working with. So remember from 13, it was like m of t, your resulting mass is going to be initial, times your doubling base, time over your doubling rate. Okay, so we're going to have 2 different equations. So we have a Sprague's, and we have a Grach's. Okay, so we have, let's do S of t for Sprague. So S of t is equal to, initially there were 1,600 Spragues times 2t over, and then the doubling times 6 years, so t over 6. Alright, and then Grach's, we'll call G of t. So initially there were 200, so it's 200 times 2t over, and the doubling times 3 years, so t over 3. Okay, so for part A, we're wanting to see how many Grach's were there after 1.5 years. So we want to see what is G of t when t is equal to 3/2 or 1.5. Okay, so G of t, let's see, is going to be 200 times 2t was 3/2 over 3. So just a little scratch work. The 3/2 divided by 3 over 1 is the same thing as 3 over 2 times 1/3, because we change it to multiplication and flip the fraction. The 3's cancel, and then I'm left with a half. So this is 200 times 2 to the half. So that should be it. So you could plug it in on WebWork as 200 times 2 to the 1/2, or like the square root of 2. And just a reminder, you guys might have different numbers than me, so you'll have to modify it to what you have. Alright, and then part B, we want to see when are there as many Spragues as Grach's. And we want to see after how many years this happens. So we want to see what is t when S of t is equal to G of t. Okay, so setting this equal to each other, times 2t over 6 is equal to 200 times 2t over 3. So I want to get the t by itself. So first I need to get rid of the numbers up front. So I divide by 200. So that cancels those. So 16 over 2 is 8. So I have an 8 times 2t over 6 equals 2t over 3. And then now I want to take the natural log of both sides. Okay, so taking the natural log, I have natural log of 8 times 2t over 6 is equal to the natural log 2t over 3. And I'm thinking maybe, because I could convert 8 into a power of 2. So that way I could combine those. Or combine the 8 and the 2t divided by 6. So we know that 8 is equal to 2/3, 2 to the third. So really this is going to be 2 to the third times 2t over 6. And so I would add the exponents. So it would be 3 plus t over 6. So now it's a natural log of 2, 3 plus t over 6 is equal to the natural log 2t over 3. Now I can move the exponents up front. So I have a 3 plus t over 6 is equal to t over, oops, forgot to write the natural log 2. Is equal to t over 3 times natural log of 2. Okay, so the natural log of 2 I could divide out from both sides. So now I have a 3 plus t over 6 equals t over 3. Okay, so I'm going to subtract the t over 6 over, so I have a 3 is equal to t over 3 minus t over 6. Okay, and then I could just combine this. So I want to get the denominator of 6, so I put multiplied by 2. So I have a 2t over 6 minus t over 6, which is just going to be t over 6, or 1t over 6. So I have 3 is equal to t over 6. So this was just the scratch work for doing this right hand side. And then I could just multiply the 6 over, right, to get the t by itself. So I have t is equal to 6 times 3, which is 18. Okay, so t is going to be 18, and that's going to be when there are as many sprogs as cracks. Okay, I hope that helps. If you need more help, remember I'll be at my office hours tomorrow and also math lab. My office hours are from 11 to 12. Math labs from 12 to 2. Alright, so I'll be there tomorrow. I'll probably see some of you guys there, but I hope that helped. And then I'll see you guys next week, and we'll be doing the exam 2 review sheet. So I'll see you guys then.